This is section 2.2. It's really kind of a day 2 continuation of the derivative rules. So before we really get into the 2.2 part, we need to go back and fill in the trig derivative rules back from 2.1. So if you go in your notes, back to, here we go. On this version of the notes, it's the bottom of page 66. We never filled in that that table with the trig derivatives. So on these, it's just a matter of memorizing. There's no developing the trig derivatives. You just have to memorize. But I do think there's a way that makes it easier to memorize them. So, for example, the sine and cosine are derivatives of each other. And what that means is that the derivative of sine is cosine, and the derivative of cosine is sine. Okay. And then I like to look at the tangent. So the derivative of tangent is secant squared. And I'm going to look at tangent and cotangent together, because if the derivative of tangent is secant squared, then the derivative of cotangent is cosecant squared. So I think those are kind of easy if you memorize those together. So like I said, I'm going to think of sine and cosine as kind of going together. Tangent and cotangent go together. And that means secant and cosecant. So I'm going to do secant first. The derivative of secant is secant times tangent. So using the same kind of idea that we did with tangent and cotangent. So if the derivative of secant is secant tangent, then the derivative of cosecant is cosecant cotangent. Okay, so those two kind of go together. Now there's one last piece that I have not filled in, because first of all, I just like to get those in your head. The next thing to know is that all of the co-functions, cosine, cosecant, cotangent, have a negative derivative. So that's a negative sign out in front of those. Okay, so basically you just have to know that. You just have to know that. So for a while, you just kind of keep that table in front of your eyes and just get used to which ones are which. So with that in mind, I'm going to go to the example on page 67 that we skipped. So if you look at number 5, if I want the derivative of 4 times sine of x, so I'm going to say g prime equals, well, remember, if there's a number in front of your function, you just leave the number alone, and then you would say the derivative of sine is cosine. Okay, bring down the minus sign. Now, keep in mind, this cosine over 2, isn't that the same as 1/2 of cosine? So let's look at it that way when we do the derivative. So again, if there's a number in front, you leave it alone, so leave the 1/2. The derivative of cosine is negative sine, and I'm going to do this. When I multiply by negative sine, I'm going to make this become a plus, because of the negative, and then sine, and that's it. Don't worry about thinking you have to simplify or combine those in any way. That's your derivative. Okay? So in general, it's just a matter of knowing those 6 trig derivatives. And now let's go to the homework that you would have done on 2.2. So now all of those that we had originally skipped, we're going to add back in. So for example, now you can add in 19 and 21 and 23. So make sure you kind of go back and circle those, know that those are added in. Maybe I'll mention number 19 for you. Don't let that theta mess you up. That theta is just your variable. That's your x. Okay, so for example, on number 19, I'm going to say y prime equals, so pi over 2 is just a constant, right? So just leave the pi over 2 alone, and then the derivative of sine is cosine. So if it was a sine theta, then the derivative is cosine theta. Okay, I'm going to bring over the minus sign. Now the derivative of cosine is negative sine. Okay, so that's it for number 19. All right. Let's see, on the next page, on page 70, now you can bring in that number 37 and 51. So all of those that we had x'd out, the reason we had x'd them out was because we hadn't done the trig derivative part yet. So now those are there. But that's all we're going to bring back in from the homework. Okay, so now we are on to page 74, the section 2.2. All right, so let's kind of take a one step back. If this is the curve 2 square root of x, so this is my f of x, find the slope. Okay, that means the derivative of f of x when x equals 2. So first of all, let's do the derivative. So f prime of x equals, so remember, we're going to think of this as 2 times x to the 1/2. So when I do the derivative, if I bring down the 1/2 and multiply by 2, that just cancels. So now I have x to the, now decrease your exponent by 1, so x to the negative 1/2, which is the same as saying 1 over x to the 1/2. So you can either write 1 over x to the 1/2, or you could say 1 over the square root of x, whatever you want. Okay, but the question didn't say to find f prime of x. The question said to basically find f prime of 2. So let's use good notation. So f prime of 2 then means plug 2 into your derivative function. So it's going to be 1 over square root of 2. No need to simplify or rationalize. That's the slope. Okay, number 2, so what we just did, we just found the slope of this curve right there when x equals 2. Find the equation of the tangent line to f of x when x equals 2. So that point that we just identified, there's a tangent line that goes through that point, something like that. Wow, that is free-handed if you can believe it. And we want to find the equation of that line. Well, remember, in order to find the equation of any line, you need a point, and we'll call that x1, y1, and you need a slope, right? Which we know is the derivative. So I know my slope is 1 over square root of 2, so I'm just going to write that down. I know my slope is 1 over square root of 2. Do I have a point on that line? Well, I know that at that point, I know that the x-coordinate is 2, so how do I know the y-coordinate? Well, if you have the function f of x, couldn't I just plug that 2 in up here to get the y value? So the y value is going to be 2 times the square root of 2. All right, so that's my ordered pair. In other words, that's my x1, y1. So now I'm going back to algebra 1. Remember the point slope? Y minus y1 equals mx minus x1. And now you know why I kept bringing that up on practice that we did in Unit 1. I think it came up on the test on Unit 1. So let's fill in. Y minus, our y-coordinate is 2 square root of 2, equals m, which is 1 over square root of 2, and then x minus the x-coordinate was 2. So that's the equation of the tangent line. You don't have to put it in slope-intercept unless they specifically tell you to, and frequently they don't tell you to. So just leave it like that. Because on a free response, if you're finding the equation of a tangent line and you go here, if you change it into slope-intercept and they don't ask you to, it's fine as long as you don't make a mistake. If you make a mistake, even though you got this correct, if you make a mistake in the computation on the next step, you're going to lose your point. Okay, so number 3, new problem. Find the slope, meaning the derivative, of f of x at the given point, meaning at this point right here, 5, 0. So let's start with the derivative in terms of x. Well, you can't take the derivative of this because of the parenthesis. We don't have any rules for that yet. So before I can do the derivative, let's multiply this out. So it's still f. It's not f prime yet. That's going to be 3 times. All right, let's square it out. 25 minus double the product, so 10x plus x squared. So f of x is 75 minus 30x plus 3x squared. Now I can go in and find the derivative. Notice I'm using correct notation all the way down. Derivative of 75 is nothing. The derivative of negative 30x is just negative 30. Plus, I'm going to use my exponent rule, so bring down the 2, 6x squared. Okay, so they said find the slope of f of x. That's the generic derivative, but they said at this point. So here's my notation. I'm going to say f prime of 5. And notice I'm just saying of 5 and not 5 comma 0 because I only have x's in my derivative equation. So I'm only going to plug in the x coordinate of 5. If there had been y's in my derivative equation, then I would need to plug in the 0 for the y's. And we'll do that towards the end of this unit. Okay, let's plug in negative 30 plus 6 times 25. I don't know, what does that equal? Negative 30 plus 6 times 25 is 150 for a total of 120. I think. Hopefully my math is right. Okay, so look at number 4. Find the equation. So up here, all they wanted me to do is find the slope. This time they want me to find the equation of the tangent line. So equation of a line, remember I'm thinking that y minus y1 thing. At the given point. All right, so what 2 things do I need? I need a point. Check. There's my point. There's my x1, y1. And now I need a slope. All right, so for the g, before I do the derivative, I need to rewrite this as a power of x. So there's the 2 that was on the top. If it's the 4th root of x to the 3rd, that means it's going to be x to the 3/4, right? 4th root, x cubed. But because that was in the denominator, when I bring it up, won't that be a negative exponent? So that's my original function. Now I'm ready to do the derivative. Use good notation. So g prime of x equals, if I bring down the negative 3/4 and multiply it by 2, I'm going to have negative 6/4, which is 3/2. Keep the x, decrease by 1. So if I subtract 1 from negative 3/4, I'm going to have negative 7/4, which is the same as saying negative 3 over 2 times x to the 7/4. Okay, so that's the generic derivative. But in order to write my equation, I need the specific derivative at this point. So I'm going to say g prime at 1 is negative 3 over 2. Now 1 to any power is just 1. So that's just going to be 2 times 1. So my slope is negative 3/2. So now I'm ready to write my equation. I'm going to say y minus y1 equals m and then x minus x1. And again, unless they specifically tell you you have to change it to slope intercept, it's perfectly fine to leave it like that. Okay, let's look at this page. So this is the graph of h right here. So, and I've got the equation for that parabola right here. Evaluate each of the following. All right, I see a mistake. Sorry about that. Notice the function I give you is h of x, but then down here it says f. That's just a typo. This should say h prime of 3, and this one should say h prime of 3. So sorry about that. Let me fix that. So h prime of 3, and this is h prime of 3. I think that's all of them. Okay, so up to number 5, h prime of 3. Well, this is h. Here's where 1, 2, here's where 3 hits the curve. I don't want to guesstimate the slope, so I'm going to use my equation up above. So let's do this. So I know that h prime of x is going to be, bring down the 2 times the 1/2, so that's going to cancel, x to the 1st minus 2, which means h prime of 3 would be 3 minus 2, which is 1. But notice I used good notation. I didn't say h prime of 3 equals x minus 2 because that's h prime of x. So be careful about your notation. You will lose points on free response when you have bad notation. Okay, so number 6, what does h prime of 3 represent? Well, remember, so yes, you could say it's the slope of the curve, or you could say it's the slope of that tangent line. So let's say that slope of curve at x equals 3. Okay, or you could say slope of tangent line. They both mean the same thing, but at x equals 3. Okay, number 7, now we kind of talked about this the other day. What's the difference between that and look here at this, h of 6 minus h of 0? H of 6 means the y value at 6. Let's see, here's 6, that looks like that point. Here's 0, that looks like that point. So h of 6 would be 7 minus h of 0 would be 1 all over 6 minus 0. So that comes out to be 7 over 6. What does that represent? Well, didn't I just find the slope between those 2 points? You could even check it out. You could say, hey, look, I'm going up 7 and over 6. Make sense? Did I do that right? Oh, I can't subtract 6 over 6. Sorry about that. Okay, so what does that represent? That represents the slope between x equals 6 and x equals 1. Okay, we said it's the slope between those 2 points, but a lot of times when it's the slope between 2 points, we'll call it the average slope. Whereas up on number 6, where it was h prime of 3, that was the slope at exactly x equals 1. We would call that the instantaneous, meaning at the exact instant when x equals 3. Whereas on number 8, it's like the average between 2 points. Okay, number 9, at what point in the graph of h will the slope be 0? Well, remember we talked about this the other day. It's going to be at that minimum point. And I think, just looking at this graph, the minimum point is right there when x equals 2. What will the tangent line look like at that point? Well, think about it. If we know that the slope is 0, doesn't that mean it's a horizontal line? Right? So you can kind of imagine the tangent line right there. It's a horizontal line. All right, so let's kind of fill in a couple things. Let's go with the one we just did. We said a horizontal tangent line means the slope is 0. So I'm going to put something here. So I'm going to say horizontal means slope is 0. But if it's a tangent line, aren't we saying that the slope is the derivative? Right? Because slope and derivative mean the same thing. So let's put those two things together. If the slope is 0, but yet the slope is the derivative, then when you see this phrase, horizontal tangent line, what should pop into your head is derivative equals 0. That's one of those things that you need to file away in your brain. And anytime you see the phrase horizontal tangent line, immediately you just spit out, oh, derivative equals 0. Okay, the other things we've mentioned, so instantaneous rate of change, remember I said that's the specific slope at one point in time. So the instantaneous rate of change is the derivative, that's the slope, at a specific point. So I'm going to say at c. It might be the derivative at 1, that's the instantaneous rate of change at 1, or the derivative at -2, that's the instantaneous rate of change at -2. So the c means a specific number, okay? Average rate of change is the slope between 2 points. That's the old days kind of slope that you did in Algebra 1. So it would be like if you have 2 points, let's say one of them is a comma something, and the other point is b comma something. So to find the slope between those 2 points, wouldn't you take the y value at a, let's do a y2 minus y1. The y value at b minus the y value at a all over b minus a. That's how we're going to write it in calculus, even though that's the same as what you did back in Algebra 1 when you said, oh, y2 minus y1 over x2 minus x1. In your mind, those two should be the same thing. Okay? So, number 10, determine the points at which the function has a horizontal tangent line. Okay. As soon as I see that phrase, horizontal tangent line, I immediately think, oh, that's when the derivative equals 0. Okay, great. So what am I going to do over here? I'm going to take the derivative, and then I'm going to set it equal to 0. Well, the derivative is 4x cubed minus, bring down the 2. It's going to cancel the 1/2, and it's just going to become x to the first. Okay, so if I want my derivative to equal 0, how can I solve for x? Oh, look at that. Dig deep into your Algebra 1, Algebra 2, pre-calculus days. How do you solve? Don't you factor? So what if I factor out an x? I'll be left with 4x squared minus 1. Am I done factoring? No, keep going. X times, can't you do difference of squares? 2x plus 1, 2x minus 1. So if there are 3 factors, that means I have 3 solutions, or 3 zeros. Either x equals 0, that is from the first one, or we could say from this one, if you solve that one, you'd have x equals negative 1/2, or if we were to solve the third one, we would have x equals positive 1/2. So that means there are 3 places on this curve where I'm going to have a horizontal tangent line. Okay? So that's the 2.2 notes, and you'll notice the homework here, it says 2.1, but that's because there's still a few questions from 2.1, and then it goes on to the 2.2. Let's see. And then on these homework pages, I would say most of them we're going to do. There might be a few you can skip. So like, for example, I wouldn't worry too much about number 3, but definitely you want to do both of them on number 4. And then all of the rest of that page 76. The thing I would point out on the next page is you can ignore part of the directions. You just want the part A on the directions where you're finding an equation of the tangent line at the given point. You don't need to do the rest of that stuff about using your calculator and blah, blah, blah. We'll do that next day in class. But otherwise, you're doing all the problems on that page. And then on the next page, notice number 67 has several parts to it, and we're doing all the problems on that page. So I know we didn't cut out that much, but just wanted to kind of mention some of those little subtleties. All right, hopefully that helps.